Let's start with some different questions today. I always start on the ends and in the back. Let's start in the middle this time. Andy, you moved to the middle. Can you give me the decimal equivalent of 7/8 to 3 decimal places?
It's point. Sorry, it's hard for me to do the multiplication in my head that fast. Because I would just multiply it out.
Okay.
Because it's 0.125 times 7. Right?
Mm-hmm.
So, I can't do it. I can't do the math right now. I can't.
Friday.
Screaming.
We're going to 3 decimal places.
It's 7.5.
Okay.
I do
David,
that one.
can I get a quarter to 3 decimal places?
Can I use calculator?
That-
Maybe 2.5.
Yeah, that one. The idea here is that you don't use a calculator. Cheryl?
0.4375.
To 3 decimal places?
Oh, right.
There you got that 7.5. Remember, we round differently in construction math. You always go to the even number. Amy, you want to get the last one?
Yeah, it's 0.125.
Okay. Cool. If you can do those in your head, you're going to do just fine on the quiz. How about, can you take these and put them into a fraction? Where are we at? Jess, how about the first one?
I have not practiced that way, I don't know.
Okay, let's see. Lisa?
That was 1560.
Elise?
Shoot.
It's a spark plug wrench.
Majed?
Well, that's hot.
You got a tough one? Gabe, how about you? You want to finish it off?
360.
Folks, I won't ask you to really put a whole lot in your minds and memory cells, because that's what reference books are for, that's what cheat sheets are for, that's what Google's for. But there are some things that I've seen over time that if you do put in your mind, it will definitely translate into speed, efficiency, and less mistakes. This is one. If I work at a machine shop and they go to 1/32, I'm memorizing every step that goes through that. Okay. If I work for a civil firm and surveying, they do all decimal feet, I'm memorizing everything that goes through that. Those kind of numbers where I work, it's imperative that you know that. If you're doing architectural, and you should probably know 2 feet's 24 inches, 3 feet's 36 inches, okay? 4 feet's 48 inches. You should know all those. Okay? Point being, these will help you out. Right now, this is probably the #1 thing you can do outside of CAD to help you out. This and command aliases, I would put command aliases with these.
Command alias.
Uh-huh. That's like L enter, M enter, those types of things. Okay, anyway, I just wanted to throw that out there, kind of see where we're at. Looks like we still need a little work. I think my lectures are going to slow down a little, so don't wait too long. We're going to do a couple things today. We're going to review scale templates right off the bat, and then we left a little bit in 13. I wanted to point a couple things out there and then hit 14. Okay. So first off, I handed one of these sheets out to all of you. We are going to do a metric template. Okay. In essence, there's 2 ways to do a metric template. One is you jump into the units command and you switch CAD to a millimeter system. In the engineering field, for metric, the millimeter is the base unit. Okay, so you type in units, you would leave it on, well, you'd switch it to, I think, decimal, and then go down and set your units to millimeters. And then you would have to then type all millimeters. You're working from millimeters from then on. Most people in America say, let's just fool it. Okay. And we use a scale factor, a conversion factor. Okay. whenever we do a metric drawing. That way we don't have to pull out our metric scale. Now, what is the conversion factor from millimeters to inches? Because that's the base unit in both systems. We know that 25.4 millimeters is equal to 1 inch. Okay? So that's your conversion factor. So if I had a measurement of 10 inches, how would I know what my millimeter is? I would times it by this ratio, right? Because this is 1 inch over 25.4 millimeters. This is 1, right? In essence, for mathematics, this is 1. I can times anything times 1, and it is itself. Okay? My inches cancel. So I would then have to draw a line equal to, what is that?
254.
254 units long. And that would be equivalent to a 10-inch line. Okay? So there's your conversion factor. We all good on that? Okay. All right, so let's set up using our A template. Let's do a metric drawing. What we're going to do is basically follow the steps for a scale template. So we're going to use this twice. We're going to do 2 here, and we're going to go fairly quickly, okay, just to get you familiar with the process. I also want to jump into an architectural, because from yesterday, I saw that the units and how we kind of input them in the architectural system was a little off, and so we need to review that also. All right, so the first thing we're going to do is we're going to do a metric template. So our starting template's the A. We know that is 11 by 8.5, that's good. Units are going to stay decimal. Now this time, we are going to 0 places for a metric. A metric rarely goes below a millimeter. Okay, so we're going to set our units to decimal in there. Now our plot scale is going to be that conversion factor. 1 to 25.4. Let me kind of zoom in on that. I see some people squinting. Gabe, maybe you can hit the light too. That might help a little. Okay. So what I'm going to in essence do is I'm going to draw this thing with English units, and then I'm going to scale the viewport by this conversion factor, and it is going to convert it to millimeters. So therefore my plot scale, these are unitless. So therefore my units are the same. One's on the left side. My plot scale has to be 1 over 25.4, or in essence I'm going to reduce this drawing by that amount. My drawing scale factor is 25.4. My annotated variable, I need to set that to my plot scale. And I think that's enough for right now, because everything else will work the same. Let's jump on CAD. If you would, open your A template. I don't know if you want to follow along, but in essence, you've got this cheat sheet that says doing a scale drawing from the template. That is the process we will go through here. So we've already done on this thing all the way through, we haven't done a save as, but we're not going to, we can just leave this. We're going to go to number 5, step 5. The first thing we do is in model space, we scale our viewport drawing aid by our DSF. So here I'll just do a scale. I grab that viewport, and when it asks me for my base point, I'll just click it anywhere. My scale factor is whatever my DSF is. Okay, in this case, 25.4. So you can scale that viewport real quick. It should get very big. So that was step 5. Oh, we've got to do 5C yet. Okay. Now, that's the annotative scale, right?
Yes.
if we want to do that. So down here where it says 1-to-1 in your status bar, you click that up, you're going to probably find there is no 1 to 25.4 scale in there. Actually, no probably about it. So we're going to do custom. Remember doing this, and then you're going to add the scale. And again, the name, you can put this as 1 to 25.4, or I'll just put mine as millimeter. You can give, it's just a name, you can name it whatever you wish. The important part is down under the scale properties, you want your drawing units set to 25.4. And just say, okay, you're done. Back down on the status bar, you can set your drawing to that annotated scale. Back over here. Make sure it now says down here 1 to 25.4 millimeter or whatever you named it. Okay, that's all of step 5. From here we go to step 6, which is paper space. So we click into paper, and in essence all we have to do here is we need to recenter that viewport that we scaled up. That's all we're really going to do. So I'm going to double click in, zoom extents, double click out, grab that viewport, set your scale 1 to 25.4. Now, what do we do down on the bottom for scale? We're doing a 1-to-1 metric drawing. So this would read 1-to-1 or full. It doesn't read 21 to 25.4. That's a trick we do behind the scenes to convert the drawing to the correct unit. We're just doing a scale factor. Now, what if you did a drawing in the metric system 1-to-2?
Next to 40.
All you do is adjust the scale that you did right here. Now, let me show you. Okay. So if I came in here and I had a scale of 1 to 25.4, that's my conversion factor, and then I had a scale of 1 to 2, I would just times those two together. And this is a 1 to 50.8. Okay. And so there is my watt scale in DSF. And I would just apply that. Now here in the title block, I would say 1 to 2. You'll get a little practice with it. Now, how is this going to work for you? I want to pull this out and show you. Not everybody do it. You're done. Okay. So you could just go to start drawing once you set that. I'm going to go back to model. And we just calculated a 10-inch line. What did that thing come up to?
250.
254 units?
Yeah.
Okay. So if I come in here, 10 inches is almost the distance I got all the way across here. Okay. So let me type in a distance of 254. There it is. Now when I go to paper space, it should already be centered. I don't think I got a printer set up, but I'll just kind of throw a real quick print out of this guy. Now we'll take this drawing, I'll put it up here, I'm going to grab metric scale, I'll show you, it's going to scale perfectly on a metric scale. So let me just grab it real quick.
Huh?
So here's that line I just drew. Now what I would then do is go to this scale, my 1 to my 100 side. So what you've got here is a tenor. So I'm just going to get on the end where you can see it. Let me kind of zoom in on this. Okay, so it's measuring, you add a 0 to all these, it's measuring 254 units. This is my millimeter scale. But in essence, when you draw on this template, once you scale it, you just draw everything. You just measure it and draw it. That's the most part about this conversion factor. You will get symmetric drawings to do so. have confidence this works. Okay, let's do one more. Let's do one more. You can either save this or toast it, I don't care. If you want to save it as a metric, you could do that template.dwt. You wouldn't have to go through those steps again. All right, let's do another one, and let's walk through the steps on this one. Let's do a scale of 3/4 inches equal to 1 foot, and we're going to use same A template. Now, we need to switch our units on this. So when you come to your units, we're going to go architectural. The precision on architectural, the standard for the industry is a 1/16 of an inch. So ever in doubt, that's what it is. That's half the distance of a saw blade. So we've got this scale that is 3/4, so what's our plot scale? Let's just work this out. So if I take 3/4 of an inch is equal to 1 foot, 0 inches. How do I find my plot scale? First off, units have got to be the same, right? That's the first step. So we're going to do 3/4 inches is equal to 12 inches, correct? Anybody need to see that step? Okay. I'm trying to get one on the left side at this point. So I got to get rid of this 4. So what I do to one side, I do to the other. So I'm left, these two cancel to 1. I've got 3 inches is equal to 48 inches. I still don't have 1 on the left side. How do I do that? I'm going to divide both sides by 3. And I'm left with 1 inch is equal to 16 inches, if my math is correct.
Yes.
Okay. So my PSF is 1/16. My DSF is equal to 16. Now, the nice part about that, this scale is sitting in your annotations bar already done for you. But at the same time, you still need to be able to calculate your DSF. You haven't seen the whole story yet on non-geometric items. We haven't done sections, we haven't done some of these other items that we need to take care of, and there's no way we still do them manually. So you gotta be able to calculate these DSFs, whether you have to set the annotation scale or not. Okay, so if you would, let's go to our A template again and open it up. Now this time we're going to do a little drawing on it besides just go through the setup process. Okay, so we're just good to go. Now, first thing we need to do, we're doing a scaled drawing, right? So the first step we do, we're again in step 5 already. We're going to scale this viewport right here by our DSF. What's my DSF? 16. Now, for your annotative scale, you want to click down on the bottom, and you should see a 3/4 to a foot. Choose that one. That one's already set up for you. Okay, that's all done. So you should see down on the status bar for your annotation scale, it should say 3/4 inch to a foot. Now the other thing we've got to do, this is an architectural drawing. So we need to reset units. I'm going to type in units. Under the length type, change that to architectural and a 16 for your precision. You still leave your insertion scale on inches because inch is still a base unit, even for a fractional system like architectural. Now, keep in mind down here on the bottom that whenever you switch these units, I'll try and give you examples of what you should try and put in here. The big thing you want to remember, what's the base unit for architectural? It's an inch. Now, many times you get over 12 inches, you're going to have a foot mark. Okay, so you got to take care of that. All right, so we'll say okay. Now, let's just finish our setup process and then we'll come back and draw real quick. go to your layout. And here you must resize this guy again, right? So just double click in, zoom extents, double click out, grab that viewport, scale it to 3/4. You starting to get kind of familiar with that process? Remember I said you would do it a lot? Seems like every day we're doing it 2 or 3 times in just lectures. Okay, any
So
questions?
on this page, you just double click on the grid, signify?
I get inside my viewport, I double click, because I just scaled my model space viewport by 16 times, it's not here anymore. Okay. Then I do a zoom extents, you should see it kind of pop up around the edges. How can I zoom in and out here? See that thing? Okay. But when you double click, it should go up around the edges, then you can set the scale right there if you want. Don't, make sure you don't spin that middle mouse wheel. I like double clicking out, grabbing my viewport, and then assigning that value. 'Cause I have spun that wheel before. All right, so we are now, well, then I go down, make sure you change these scales, folks. So here I would put in that 1/3 is equal to 1 foot. Now, let's go back to model real quick. Now, let's say we're getting ready to draw, I don't know, let's draw an 8-foot wall here. Now, we're going to use OBJ lines. And let's draw the bottom plate first in. So we'll just make an 8-foot wall. This will be a wood wall and with the studs. Okay, it won't have drywall on it. We're just going to draw the framing of it. Okay, so in this case, you need one bottom plate. So when you click a point, okay, so I'm just drawing in the line command. I clicked a point. Now, I want to go 8 feet. Okay, so if I want to go 8 feet, I need to hit the 8 and then the foot mark, which is the apostrophe. Or type 96, because the base unit is an inch. 8 times 12, there's 12 inches to a foot, is 96. So to get that, you need to hit an 8 and then that apostrophe and then hit enter. Okay, so you should be sitting there with an 8-foot line. And you see how you make a line with the units? Did everybody find the foot mark? Okay, you can go 96. It's faster to go 96 than it is 8 feet. Okay, if you got those in, because you're on the numlock pad, right? You're not moving all over the place. Okay? That's why I say some of these numbers you want to know. Now, we need to now, yes?
If our line goes all the way off the page, what?
Maybe you forgot to scale it. You check DI and check the distance on the line. If it tells you back it's 8 foot, you forgot. Just click on both sides of the line with the distance. Okay, now let's just offset off for the bottom plate. Now this is an inch thing. Typically 2x4s are 3.5 inches wide. So I'm going to do an offset, and it's 3.5. Now this is a fractional inch system. Okay, so how do I put in 3.5? Do I do 3 1/2? No, because there's spaces in here, right? It won't take this. Most of the time you cannot get this thing to work. And it's kind of weird. One time you'll get it to work, and the next time it won't. You're much better putting in 3.5. Hence, why we know this stuff. So if I want to use the offset for the top of it, I'm going to do an offset of 3.5. Because that's the size of my material. We draw full size. So I'll do an offset of 3.5. I'm going to throw this line up. There's my bottom plate. Now the top of the wall is an 8 foot. So I'm going to then offset, let's see, what is it? 92 5/8, I believe, right? For an 8 foot wall.
That's what it is.
Okay. So we're going to offset to the top plate. So 92 5/8 inches. So your offset is 92.625. offset that down 3.5, or, yeah, 1.5 inches. Did I make those
You should
3.5
go up
inches?
3 foot.
I never looked at it.
Yeah, I was confused for a minute, I don't wanna say anything, but.
No, should have. A 2x4, every time we're looking at a 2x4 flat here. And I was talking and chewing gum at the same time I said this. I tilted it up this way. You always, this is the bottom plate of the 2x4 lane flat. So it's 1.5 inches thick. So we've got the bottom and the top right now, so we're gonna switch, delete that first one out. So you should just be sitting with 2 lines, your top and bottom line.
Wait, how did you offset that again?
I'll tell you what, here folks. Start with 1 line. Let's just correct it right here off the bat.
Yeah, I've done it before, I've done it with actual boards and screwed.
Yeah, so have I. Okay, we're starting with 1 line across the bottom. You all good? Okay, offset 1.5. Oh, enter 1.5. Okay. That should give you your bottom board. Okay, now we're gonna go for the stud height. Offset, 92 5/8. Because remember, we're in our base 8-inch system, so 92.625, because 5/8 is 625. And you're gonna take that top of that board right there, I've got mine highlighted, and throw it up. Now there's 2 top plates, so we're gonna do an offset of 1.5 and offset that top one up twice.
1.5?
1.5, if you're looking at the 2 boards.
2.625.
92.625,
Or we do it on
92,
top of
5/8.
the-
Standard
on top of
8-foot
those or
stud
the
height.
bottom?
Huh?
The top of that one or on the bottom?
Yes, offset them up.